Good morning viewers and welcome to this session of EduSat. In today's session, we will discuss about DC circuits, and in DC circuits, we will discuss Ohm's law and about current, resistance of a conductor, and then we will discuss temperature dependence of resistance, and then we will discuss about resistances in series and parallel. So, first of all, we will discuss about what is current, electric current. Whenever ends of a conductor are placed at different potentials, suppose this is a conductor, this is end A of the conductor, this is end B of the conductor, and this end A is at potential VA and end B is at potential VB, such that VA is greater than VB. So, end A of the conductor is at higher potential and end B of the conductor is at lower potential. When this happens, the charge will start to flow, the positive charge will start to flow from the end of the conductor at higher potential to the end of the conductor at lower potential. So, this flow of charge through a conductor is called electric current. And how it is defined? Suppose I consider a cross section of this conductor, and through this cross section of the conductor, the amount of current delta Q flows in time delta t. Then electric current through this cross section of the conductor is defined as I is equal to delta Q over delta t. That is, the charge flowing through the cross section per unit time is called electric current. Now, if this interval delta t is large, then this current is called average current. But if this interval delta t is infinitesimally small, that is delta t tending to 0, in that case the current can be written as limit delta t tending to 0 delta Q over delta t, and this is equal to dq over dt. This is called instantaneous current. So, instantaneous current is rate of flow of charge through the cross section of a conductor. Now, what are the units of current? Charge is measured in coulombs, time is measured in seconds. So, units are coulombs second minus 1, and 1 coulomb second minus 1 is called 1 ampere. So, units of current, electric current are amperes. Now, how much current is 1 ampere? If delta Q is equal to 1 coulomb, in time delta T is equal to 1 second, then how much will be the current? Current will be 1 coulomb over 1 second, this is equal to 1 ampere. So, how much current is 1 ampere? The current is said to be 1 ampere if a charge of 1 coulomb passes through the cross section of a conductor in 1 second. So, this is called 1 ampere of a current. So, next we will discuss about electromotive force. Or in short we call it EMF. Now, as we have just now discussed that when the ends of a conductor are maintained at different potential, the current is set into the conductor and charge starts moving. Now, how to maintain the agency which maintains the potential difference across the ends of a conductor is called source of electromotive force or source of EMF, and one example of such a source is cell. So, cell is a source of EMF which maintains the potential difference across the ends of a conductor. Now, let us consider a conductor. And a cell is connected to this conductor. This cell will maintain a potential difference across the ends of this conductor, and as a result of this potential difference, the charge will flow through this conductor. As you must have read in previous chapter that charge flows from the point at higher potential to the point at lower potential. This is when positive charge is free to move, but actually in conductor the electrons are free to move. So, these electrons move from low potential side to the high potential side. The positive charge moving from high potential side to the low potential side constitutes a current which is called conventional current, and the electrons moving from low potential side to high potential side constitute a current which is called electronic current. So, conventional current is basically opposite to the direction in which the electrons are moving. Now, the potential difference across the ends of this conductor is maintained by this cell which is called source of EMF. Now, what is EMF? To move the charge through this conductor, energy is required, and this source of EMF supplies the energy to the charge carriers. So, EMF is defined as the energy per coulomb provided by this source of EMF to move the charge through the circuit. So, it is basically work done per unit charge by the source of EMF to move the charge through the conductor or through the circuit. So, as this EMF is work done per unit charge, units are joules per coulomb, or 1 joule per coulomb is called 1 volt. So, EMF has got same units as those of potential difference, but there is a basic difference between EMF and potential difference, that even if this circuit is open, even then the difference in potentials of this cell exists, and this difference in potential of the cell is called EMF. So, there is another way to define EMF, that it is the potential difference between the ends of a source of EMF when no current is flowing through the circuit. So, this is called EMF. Next, we will discuss about Ohm's law, which is quite an important law. Again, consider a conductor. Across the ends of this conductor, we create a potential difference with the help of a source of EMF. The Ohm's law states that the current flowing through this conductor, let it be I, the current flowing through this conductor is directly proportional to the potential difference created across the ends of the conductor. If V is the potential difference across the ends of this conductor, then current which will be set into this conductor is directly proportional to the potential difference across the ends of the conductor, provided that physical conditions of this conductor remain unchanged. So, what are those physical conditions which must remain unchanged? Physical conditions of temperature, humidity, etc. remaining unchanged. The current through a conductor is directly proportional to the potential difference applied across the ends of conductor. So, taking R as constant of proportionality, we can write this equation as I is equal to 1 over R V, where 1 over R is constant of proportionality, or we can rewrite this equation as V is equal to I R, where V is potential difference applied across the ends of the conductor, I is current flowing through the conductor, and R is constant and this constant is called resistance of the conductor or resistance of the material. So, from this equation you can see that this appears to be an equation of a straight line. Compare this equation with y is equal to mx plus c. So, this is an equation of a straight line, and we can verify this Ohm's law in laboratory. How we verify this Ohm's law? Take a resistance. The symbol used for resistance is this. And connect a source of EMF across this resistance, an ammeter which will give the current flowing through the circuit, and a voltmeter connected parallel to R will give the potential difference. We want this source of EMF to be variable. So, we connect a rheostat. So, applying different values of potential difference across the ends of this resistance, we note down the amount of current flowing through this resistance and plot a graph since V is independent variable. It is taken along x axis, current I is dependent variable, it is taken along y axis, and our equation is I is equal to 1 over R V plus 0. This can be compared with y is equal to mx plus c, where c is the y intercept. So, if you plot the graph of V and I, you will find that it is a straight line. With the slope of this graph, how will you find the slope? Take one of the values as V1, some other value of voltage as V2, note down the corresponding current I1 and I2. So, this will give you the slope is tangent of the angle made by the line with the x axis. So, how much is this side? This is I2 minus I1. How much is this side? V2 minus V1. So, slope of this line is equal to I2 minus I1 over V2 minus V1, and from this equation this slope is equal to 1 over R, or you can write R is equal to V2 minus V1 over I2 minus I1. So, in this way you can find the resistance of and the unknown value of resistance, or you can verify the Ohm's law in the laboratory. If this line is straight, that means Ohm's law is verified. Now, let us discuss about resistance in detail. Consider a wire of a material across the ends of which we have applied a certain potential difference. This material contains some free electrons and heavy ions also. Which we call them kernels. So, when potential difference is created across the ends of the conductor, the electrons start moving from the end at low potential towards the end at high potential. Now, during their movement through the material, they undergo large number of collisions with the surrounding atoms, electrons or kernels, and as a result of that, these collisions, the material of the conductor through which the charge is flowing offers a hindrance to the flow of charge through it. This hindrance offered by the flow conductor to the flow of charge through it is called a resistance of the material. So, what is resistance? It is hindrance. Resistance is the hindrance offered by the material to the flow of charge through it. So, there are various factors on which this resistance depends. In Ohm's law, we have written V is equal to I R, or from this equation you can write R is equal to V over I. R is equal to V over I. So, units of potential difference are volts and units of current are amperes. So, units of resistance are volts per ampere, and 1 volt per ampere is called 1 ohm. The symbol used for ohm is capital omega, Greek letter capital omega. So, R is equal to V over I. If V is equal to 1 volt and I is equal to 1 ampere, then how much is resistance? Resistance R is equal to 1 volt over 1 ampere is equal to 1 ohm. So, this defines the unit ohm for resistance. Resistance of a material is said to be 1 ohm if a potential difference of 1 volt results into a current of 1 ampere in the material. So, how resistance is defined? Resistance of a material is said to be 1 ohm if a potential difference of 1 volt across the ends of the conductor sets up or results into a current of 1 ampere through that conductor. So, this is unit of resistance, which is called ohm. Next, we will discuss various factors on which the resistance of a conductor depends. The resistance of a material, first of all, depends upon the length of the material, length of the conductor. So, it is found that larger the length of the conductor, more is the resistance. So, resistance is directly proportional to length of the conductor. The second factor on which resistance depends is area of cross section. Larger the area of cross section, more conveniently the charge carriers can move from one end of the conductor to the other end of the conductor, and lesser will be the resistance of the material. So, resistance of the material is inversely proportional to the area of cross section of the material. Third factor is nature of the material. Resistance of the material depends upon the nature of the material also. If you take two wires, one of copper and the other one of iron, both wires having same length and same area of cross section, obviously the resistance of copper is much less than that of the iron wire. Though their lengths are same, their area of cross section is same. So, this indicates that the resistance of the material also depends upon the nature of the material. The fourth factor on which resistance depends is temperature. Temperature also decides the resistance of the material. So, we will combine all these factors, leaving temperature aside, assuming that the temperature, surrounding temperature of the material remains constant, the resistance of the material will be given by rho L over A, where L is the length of the conductor,